Okay, class, and we continue 6.4 today. Okay, remember last week a few formulas that given, right? So I hope you have written down the formula. So now let me prove to you, okay? Because you're asked to prove the following identities. So remember last week, I gave you a few. So now listen to me. How are you going to prove this for the identity? Okay, so class, before I start to prove this, so we do some revision about the formulas that I already explained to you all. Yeah? Okay, the formula for sine, cosine, tangents, you remember? The formulas that needed. So if you haven't written down, please do it so. Yeah. So I gave you tangent theta, that is sine per cos. Then cotangent. Cotangent, that is 1 per tangent. Okay, 1 per tangent means you can reciprocal this. Then secant theta, 1 per cos. Then you can exchange one. Okay, then cosecant, that is 1 per sine. And then cotangent, what else that given? Okay, wait. I remember I gave you a few for sine square theta plus cos square theta that equal to 1 and so on, right? So, okay, wait, class. Meaning that for 6.4 partner, yeah? So, sine square plus cos square that equal to 1. Then I teach you how to shift it one, right? Okay, next. 1 plus tangent square. Last week, I even proved to you everything already, yeah? Okay, after that, for 1 plus cotangent 1. Remember, I have drawn the triangle to show you how I get, right? Okay, so class means that we need these 7 formulas to prove, okay, to prove from left to right or from right to left. Remember I said that I asked you to choose those that complicated side to the easiest one. Okay, now by referring this, I hope you have copied down. Any of you that not yet, please do it so because you need to refer this. Yeah, because I'm not going to write out all this each time. Just to tell you which formula to choose to prove from left to right or from right to left, okay? Yeah, copy first, Okay, now look at question 1. Okay, so normally I like to choose those that got 2 terms to become 1 term. See, like this, Okay, or we see that complicated side, Okay, we see A. Okay, now we see, for example, look at A, cotangent theta plus tangent theta. Okay, so now I want to prove it to the left side because just a minute. Okay, you see? Remember last week I said, right? Once you see this, okay, the answer that given is cosecant theta, secant theta. Okay, then I said that, okay, you can do some, whatever that you can change, you change from here, then, or from top to bottom, or bottom to top. You can try to make it a few lines from top, a few lines from bottom. Now, whatever that can change. Okay, for example, just cosecant. Okay, cosecant, you know that is 1 per sine, yeah? Secant is 1 per cos. Sometimes here can change you some. Okay, so means what we can do now from top, as you know, cotangent. Cotangent, because you see under here, I want to make it sine and cos. Yeah, I want to prove that sine and cos, so I'm not going to use tangent. I'm not going to use 1 per tangent. So I make it cos per sine. Tangent, sine per cos. Or sin per cos, yeah? Okay, like what I say, whatever that I can change, I change, yeah? And then you see from here, always when you see to make it a fraction, plus or minus for the fraction, we make it to the same denominator. So here I multiply with cos theta. Here I'll multiply with sine theta. Okay, class, can you see the bottom part, the denominator came already? So what I have for the denominator here is, I follow here, yeah, sine per cos. Yeah, sine per cos, sine per cos. And the top part, I got cos square theta. Remember I said you cannot write cos theta squares, remember? So the way like that, we have to write cos square theta plus sine square theta. Okay, class. You see, we got cos plus sine square one there. This formula for number 5. So cos square plus sine square theta, we got 1. Okay, so here I write 1 per sine theta, cos theta. Okay, then we can join this already. Can you see that? 1 per sine, multiply 1 per cos. Can you see? Then I got the answer. So means here you can see that proven. So you understand what I meant to that? From top, you can do some. From bottom also you do some. Then we can combine it, okay? Got what I mean? Yes, huh? Okay, so like write down anything that needed first class. Then ask before I delete, huh? I will show you all this first. Then later on only I'll let you try some, yeah? Okay, can follow so far? Done, yeah? Okay, now we go B. I look at B. See the left side also? I make it the left side. 1 per 1 plus sine theta plus 1 per 1 minus sine theta. Okay, what we want is 2 secant square theta. Okay, class, before I get secant square, most probably I get 1 per cos square. Remember, secant is 1 per cos, there? Secant is 1 per cos. If both single term, I make it square. Here also I can square both sides. Okay, square both sides, yeah? So, okay, we have a look here. To make it the single fraction, here we got 2 terms. So now to make it a single fraction, class, okay, what I can do is I multiply these two. Means here I multiply with 1 minus sine theta. And here I multiply with 1 plus sine theta. Okay? So now class, see my denominator here. A plus B, A minus B. Okay, so I hope you still remember, yeah? Wait, I write this formula. When you see A plus B, A minus B, so you can expand it as A squared minus B squared. Okay, so see here, a square means 1 square is 1. Minus b square means sine square. Okay, on top, we see 1 minus sine theta plus 1 plus sine theta. Okay, next, you see, minus plus eliminated. Okay, we can see the answer nearly came out. So I got 1 plus 1, 2. 2 per 1 minus sine square theta. Okay, class, you see? 1 minus sine, see from here? Okay, see this one? When I shift the sine square theta here, 1 minus sine square theta, I got cos square theta. See? Like that, I got cos square theta from this formula. See that? Okay, so now we see, we have done. Because when come to this part, so I shift the 2 here, 1 per 1 per 1 minus sine square means cos square. Okay, can follow so far, class? Yes, okay, same thing right now. Make sure you understand all the steps, yeah? Now get ready to C. I done until C, then I let you try D and E. Yeah? Okay, get ready, C. So C, same thing, the left side, 1 plus tangent square theta, 1 minus sine square theta. You're asked to prove to get 1. So 1 I can't write now because many that can make 1. Yeah, many that can make 1. So I can't decide from here. So what I can do is, okay, you check and see. 1 plus tangent, okay, class, see here? Look at this first, I show you. 1 plus tangent square, see? This part, 1 plus tangent square, so you write down secant square theta. And 1 minus sine square, there, like just now, 1 minus sine square, I write down cos square theta. Okay, I get it from these two. You refer your 5 and 6 class. Okay, so this part, 1 plus tangent, just now I say is secant, yeah? Secant square theta. And 1 minus sine square is cos square theta. Again, secant is 1 per cos. Cannot, secant again. Back here, you refer your, number 3. Because I say if both side, I can square both side. Square both side becomes secant square, cos square. If single term, left and right single term, only I can square both side, class. Like you see, 5, 6, 7 is not a single term, not a single, so I can't square both side one. Take note of that, yeah? Okay, now back here. There you see the answer came out. This one I simplify, there I get 1. Okay, so proven. Okay, got it, class? Okay, now your turn. You try D and E. Have a try D and E and see. Okay, keep trying, D and E. Yeah, 2 more minutes for you to try, yeah, class? Okay, should I have done, class? Any of you need help? Any of you? Both can, huh? Okay, good. All can, huh? Any of you need help? If yes, you let me know. I show you how to do. Can get, huh? Okay, good. Now let me go through question 2. Sure, huh, all of you? If any of you couldn't get, you must let me know. Then I show you how. Can, huh? Okay, good. Now we go number 2. And listen to me. How are you going to do number 2? So same as usual. I'll show you the first maybe A then B. Okay, with the power 4. Yeah, then later because you see D, we got power 4 one, huh? Now listen to me, number 2A. Okay, so I get from left side. Okay, you're asked to prove until cos square theta. I think it's not that hard, yeah, class, for these questions. Sometimes you see that looks complicated, but actually it's not. Okay, because I want to prove until cos. So cotangent, I'm not going to choose 1 per tangent. I choose cos per sine. Okay, remember 1 minus cos as well? Yeah, you make use of this one. 1 minus cos is sine square theta. Okay, 1 minus cos. And then just now cotangent there, I choose this one. Yeah, I choose this one. Remember just now I say, from number 1 until number 4 only, we can square both sides. Yeah, so class here, I get sine square. Okay, see, sine square and sine square, I can simplify. Then I got cos square theta, proven. Okay, now, proven here. Okay, now look at B. So can follow now for number 2A. Okay, now look at B. Then for B, the same thing, class. Okay, we can have a look. Let's say you got power 4. You don't worry about the power 4. So you see how I do? Like what I say, right? I like to use 2 terms to make it 1 term. But it depends. Depends on the questions. Okay, class. So from the answer here, okay, what I have is sine power 4 theta secant square theta. Remember I said whatever that can change, we change. Whatever that can change, we change. So tangent, okay. What I need is sine and secant. As you know, secant is 1 per cos. 1 per cos. So you see 1 per cos and sine. So I change everything to sine and cos, yeah? Tangent, okay, I make it sine per cos. And here is sine square theta per 1. So class, I make it same denominator. Okay, so let's see how I do, yeah? So means here I got cos square theta. Cos square theta for the denominator. And here I got sine square theta. And I got sine square cos square theta. And then class, you see this? Sine square theta came out twice. So I factorize it. Sometimes you can see with two terms, with what we can factorize, you can factorize, okay? So sine square, take it out, left 1. Sine square theta, take it out, left cos square theta. I think the answer nearly came out. So we see sine square theta. Okay, again, class. 1 minus cos, formula number 5. Yeah, 1 minus cos, we got sine square theta. So here I got sine square theta. Okay, not enough space now. Wait, per cos square theta. So here the question asks is sine power 4 theta secant square theta. Okay, now you see sine square and sine square. So I write sine power 4 theta. And here I write it separately, 1 per cos square theta. Where 1 per cos square is secant square. Then again, I prove the answer. Okay, can follow? Okay, now your turn, class? Okay, you try C, D, E, then see. Copy this first, Okay, copy this and try C, D, E. Keep trying, yeah? Yes, George, you can't get. Okay, George need help for C. What about if you need help for C, okay, listen to me. If not, you can keep going, yeah? I'm going to explain C now, yeah, class? I look at C. Yeah, once you can't get, you let me know. C, yeah, okay, like George, listen to my explanation. Okay, I think C a bit complicated, right? Tak apa, listen to me, yeah? C, George, you use left to right also, right? Yes, okay. Because I asked you to choose a complicated one to solve. So, okay, look at my explanation here, George. Or any of you that need help, yeah? So you're asked to prove until you get secant theta plus cosecant theta. Okay, remember I said from top or from bottom. Okay, from bottom, I can see secant is 1 per cos. And from cosecant, I can get 1 per sin or sine, yeah? Then after that, maybe I can't do anything yet. Oh, okay, I can make it to the same denominator, for example. This one I multiply with sine theta. And sine, and this one I multiply with cos theta. So the denominator becomes sine theta, cos theta. Sine theta, cos theta. Okay, so maybe not yet because I can't see anything that I can do here. Okay, so now I continue this part. So what I want to make it is all, you see, before I prove to here, this part. I can see that the terms that needed is for sine and cos only. Sine and cos, okay? So since here is already sine and cos, okay, maybe I leave it first. Here I change it that with the sine and cos one, yeah? Sine theta per cos theta for tangent. And cotangent, cos per sine. Same like normal, I'm not going to use the tangent one, yeah? Okay, so this one I remain unchanged first because all this for sine and cos. Here, okay, I make it same denominator. I made the denominator as sine per cos, sine cos, sorry, sine theta, cos theta. Here I multiply with sine, I get sine squared. Remember just now the previous question, we have this like this, yeah? So this one I multiply with cos. Okay, so you see this formula again? This one is 1, remember? Okay, yeah, so this one I know is 1. So I write this remain unchanged again. So here 1 per sine cos. Yeah, you see, came out already. Okay, I can join to here already because this one sine theta plus cos theta times 1. Sine theta plus cos theta. See now? Okay, so means I can join to this part. There, proven. That's why I say, right? I ask you to write a few from top, a few from bottom, then it can join already. Okay, maybe in exam, how? Let's say you leave some space here already, how? That's okay. Like if you leave some space here, maybe you just put something that cut it or you can copy it up to you. Okay? Is that clear? Okay, right? It's or maybe you can delete this one, just write a bit up. Or maybe you pretend you don't want to delete anything. So, okay, maybe you just pretend that, okay, you write like this, sine theta, cos theta, because you multiply, and you write sine theta, cos theta. But it's the same, right? It's the same, right? You purposely, right? Yeah, purposely do it like this, then, okay, then you cancel it. You cancel it, then you just write it. The rest that means you can have the following steps already, right? Then you tell proven. Okay? Remember last week I even taught you, I say you start from few steps here. You start from then you from bottom up here from top to bottom. Then maybe this part, okay, you purposely you actually you can't get, let's say. This question you can get. Sometimes you still can't get. Tak apalah, you just leave it something here and then you cancel it, then you tell proven. Okay? Understand that, yeah? Actually, it's not that you can prove, but from few from top, few from bottom, you join it, then you just tell proven. Okay? Okay, keep trying. D and E. So George, write down the steps. Can follow now? Yes, okay, good. I keep trying. Need help also for D, yeah? Okay. Right, so class, same students that need help for D also. So can I delete C? So I delete that. Okay. So make sure you ask if you want me to repeat, ask before I delete that class. Okay, now I go which one? This one? D, right? At class, let me explain D to y'all. We got sine minus cos power 4. Okay, so since Yan Sim and George and also Ray, you all can get this right. What about you, Chia? Can get or not? Can get also. Okay, most of you can get, huh? Yeah, most of you can't get class. Okay, when you see this type of questions, I hope you still remember. A square minus B square, remember? Yeah, two terms. The center with the minus. Both are perfect square, remember? So you apply A plus B, A minus B. Okay? So before I continue, okay, let me see. The answer is 1 minus 2 cos square theta. Okay, I think nothing for me to change here. Yeah. So because if you change to cos square theta to become sine square theta is more or less the same. So I decide to start from here. Okay, with the plus and minus, this formula. Sine power 4, I make it sine square. Okay, not sine square. Then the cos power 4 also, I make it cos square. Sine square plus cos square, is it 1? Can I? Because this is 1, right? 1 times this is 1. Okay, I'm not going to write this, just to show you from here. Again, the formula for number 5. Sine plus cos with the square. 1, okay? So here, class. Understood that this is 1. 1. 1 multiplied with this will remain the same, right? So you get sine squared minus cos squared. Okay, what I want is 1 minus 2 cos squared. I want remain the cos squared. Yeah, so we back here. Sine is 1 minus cos squared. Okay, that's not the formula of this one. Sine squared plus cos squared is 1, right? So shift the cos over there. 1 minus cos is sine squared. Okay, class, see? 1 minus cos squared theta minus again cos squared theta. Then 1 minus 2 cos squared theta. Done. Okay, that is the same like you do 1 minus A minus A. You got 1 minus 2A. Okay? Yes, okay, let's keep trying E. Oh, also can get. Okay, not bad. It's okay as long as you try. You still can get, listen to me. It's okay. I judge, huh? Yan Sim also can get, right? Okay, look at E now. Let's make it, maybe you're still not used to these questions yet. It's okay. Yeah, look at E. So I get the left side. Now I want to prove it to the right side of tangent square theta. I think tangent square, okay, I'm not sure which to apply because tangent square, you see? Tangent square, maybe we can get secant square theta minus 1. Or tangent square, maybe I can get sine square theta per cos square theta. Can I? So I'm not sure. Wait, this is cosine. I'm not sure. Okay, I try to use this and see. I'm not sure, yeah? So if you can't get that, then only you change, okay? I try to use this one. So before I get tangent square, maybe I get from sine square theta per cos square theta. And then sine square theta, maybe I'm not sure also. Okay, apa? We get some from top, yeah? Okay, class. I think I make it like this. Since that what I have here is before I get tangent, I got sine per cos, right? Yeah, sine per cos. So now let me check and see what I can do here. Because a few questions that I can choose. 1 minus tangent. Okay, let me see. 1 minus tangent, what I have here. No, this is 1 plus tangent, not 1 minus tangent, yeah? And then the down part also here is not 1 plus. That's why I can't apply this one. This is cotangent minus 1, not 1 plus cotangent. So I can't apply this also, okay? So what I can do, okay, I make it slowly. Okay, I make it 1 minus tangent, so sine per cos. Or the one here, I think I do it like direct, yeah, class? 1, okay, I just make it, since this is sine per cos. So the one here, I think I make it cos per cos. And here, sine per cos. Because I choose to make it to the same denominator. Okay? And here, the big pearl, since I got 2 pearl here already, the big pearl, I make it divide. Okay? So I do the same thing. Cotangent cos per sine. Minus 1, okay? 1 sine per sine. Or sin here. Okay, so now I got cos square theta minus sine square theta from the top. The denominator is cos square theta. So I still make it divide first. Later only I do the reciprocal, yeah? So the top part, I got cos square theta minus sine square theta per sine square theta. I think I nearly see the answer, yeah? Okay, so cos square theta minus sine square theta. Here I just copy because I want to make it this as reciprocal. Yeah, I think I got the answer already, class. Okay, then this one, we can simplify. Left sine per cos, sine square per cos square, and proof. Okay, already proven. Can follow? Yes, okay. What about Yan Sim? Is it okay for you, Yan Sim? Yes, okay, good. And write down. Okay, so number 3 also proven one, because later we still got more. Yeah, we still got more to prove. At the moment for this, how many formulas? Just now, 7 formulas that we proved from 6.4 there, yeah? Okay, done, yeah? At class, look at number 3 also prove. Yeah, same. I think I choose the right side because the left side is too simple. Yeah, too simple, not complicated. It's very hard for me to prove. Okay, so like class, listen to me. I show you number 3A, the right side. 1 per class, remember, yeah, for this, you can't shift anything to the left or right. No, not allowed to shift one. Okay, so wait, now let me see, because this is cos theta. Cos theta, I think nothing for me to change, okay? So I need to do from top to bottom. Yeah, we can see here 1 plus tangent square. 1 plus tangent square, then I think I got a formula, right? Then you see this formula, 1 plus tangent square. I can change it to secant square, okay? Secant, yeah? So means here 1 divide square root of secant square theta. Okay, class, you remember this one? If A with a square, we got A, right? So what I can see from here, secant square theta means I got secant theta. And that proof 1 over secant is cos. See that? Then this formula number 3. Secant theta is 1 per cos. So 1 per secant is cos. That already proved. Okay, got it, class? Okay. So I explain one more, yeah? Then later I let you try. Okay, look at B. Oh, still need, yeah? Okay. Now I delete. I erase this first, because I need some space. Yeah, sorry, yeah, class. I can't delete the whole thing because the top part still need to show you. Okay, now get ready to my section B. Okay, for B, I have a look. I choose the same, the left side, yeah? Left side to right side. Looks complicated? I think it's not, because can be seen that I just need to expand. So I want to get 2. Okay, see how? So class, now I expand this one. Cos square theta, because as you remember, A plus B square. A plus B square means I got A square plus 2AB plus B square. And the same thing here. A square minus 2AB plus B square. Okay, so class, you see that cos square plus sine square is 1. Get that? Yeah, that cos square plus sine square is 1. The yellow one, 1 plus 1 is 2. And here can you see plus 2 sine theta cos theta minus 2 sine theta cos theta means eliminated. So here 1 and here 1. Okay, then maybe you can write one more step. 1 plus 1, then we got 2. Then proven, okay? Up to you. You can recopy this one, you put a bracket, then you plus this, you put another bracket, then only you tell 1 plus 1 is okay one. Okay, can follow so far? Yes, okay, class. You have a short break. Later, you continue C to E, yeah? Okay, have a short break. Okay, class, we continue, yeah? So, okay, keep trying D and E. No, sorry, C, right? C. Okay, keep trying. If you need help, you let me know, yeah? Oh, have tried and need help. Okay, next class. Got students that have tried but still can't get. It's okay, I think I'll explain this one to y'all. Okay, we see cotangent. Before I get cosecant, most probably I get 1 per sine square theta. Okay? So cotangent, okay, cotangent, I make it cos per sine. Divide, I make it big per as divide. Tangent is sine per cos. Okay, 1, I make it 1 first. Later when I decide how to make it to the same denominator, yeah? Cos per sine times, okay, this one I make it cos per sine reciprocal. Last one. Okay, so I can see cos square, cos times cos, cos square, sine times sine, sine square. I think the answer nearly came out. And now I can decide the one already with the same denominator. Okay, sine square, I got sine square here. Cos plus sine square there, I got 1. Okay, done, proven. So remember this formula just now? I said the formula with number 5, right? If not mistaken. Wait, now let me check and see. Wait, my mouse here got problem. Okay, hold on, class. It's out of battery. Let me change for a while, Okay, sorry for waiting. Okay, so should be okay, class. Next, let me continue E. E. No, D, right? We have done C, yeah, okay. So D also need help, right? I look at D. D, okay, I make it to the same denominator. So yeah, 1 plus cos, 1 minus cos. So I get 1 plus cos theta multiply with 1 minus cos theta. Remember just how we have these questions? A plus B, A minus B. I forgot which already. It's okay, you refer, yeah? And here, class, this one I multiply with 1 minus cos. I mean this one, and this I multiply with 1 plus cos. There, minus and plus eliminated, left 1 plus 1 is 2. And down here, a plus b, a minus b, I got a squared minus b squared, okay? To make it single, just now the formula, 1 minus cos square theta. So it's sine square theta. Okay, 2, right? 2, you see, I write it separately to show you. Actually, here you can direct to this answer already. Okay, 1 over sine square theta. 1 over sine means cosecant. So I got 2 cosecant square theta. Now, is it okay now? Okay, keep trying E and see. Done trying or still? Still, okay. Copy this and try E. At least one question to try and see because I had explained from A to D already, yeah, class? Okay, done, right? Yes, okay, some can get, some have done, yeah? Any of any help for E? Oh, Ray, you can't get, okay, tak apa. Since any one of you, if you couldn't get, for sure, I explain to you all. Okay, Ray, look at my whiteboard here. Now, so to make it to the same denominator, this one multiply with this. So square, okay? This multiply with this. So I got cos square. Okay, then the denominator, I get cos theta times 1 plus sine theta. So to get 2 secant theta, most probably I get 2. Secant is 1 per cos. So that secant is 1 per cos. Okay, I try to get this and see, yeah, class? Now, we see a plus b squared. A plus b squared, I expand, I got a squared plus 2ab. And then plus b squared. And this one remain. Cannot until here? Then in class, normally, because student asked me this before. For the denominator, okay, we need to expand or no need. Normally, when we do this type of questions, we try not to expand yet. We see the conditions. Yeah, most of the questions when I do this one to prove one, I'm not going to expand the denominator. Numerator, yes, because I see whether I need to simplify. If not, only I expand it. But most of the time, we don't expand for the denominator, okay? So class, okay, see what I have here. 1 plus 2 sine theta Okay, can you see cos plus sine, that is 1 again? And just now the formula, sine squared plus cos squared theta. Sine squared plus cos squared is 1, eh? Okay. Then 1 plus 1. 1 plus 1 is 2. Okay, I think the answer nearly came out. Okay, so you see here we can factorize the 2. Left 1 plus sine theta. This is why I explained to you all, I said not to expand the denominator yet, because you see, without expanding, here I factorize, I can simplify it. Okay, then I get 2 per cos theta, then 2 per cos theta, so proven, yeah? Okay, that's all for temporary 6.4. All these 3 questions to show you how I prove it. Okay, Nat? 6.4, can follow all of it? Yeah, I get ready to 6.5. So for 6.5, just now we have done one is basic, the basic identities, yeah? Okay, so for 6.5, we are going to do the addition formula and also double angle formula. What are all these? So just now, other than the, how many, I forgot already, 7, huh? Other than this 7, okay, we got another 6, huh? Another 6 to show you. Okay, so class, I'm going to explain another 6. So any that needed, you write down, huh? Okay, wait, I delete all this first because I need the space to show you the rest, yeah? Okay, now I continue this. Just now, 1 until 7 are the basic identities, the basic formula. So now I'm going to teach you addition formula and also double angle formula. Yeah, what do you mean by addition formula? So now I go addition formula first, yeah, class? Addition formula means if I give you sine A plus B. Okay, class? So normal, let's say we have A, B, and C. You expand, then you get AB plus AC, right? Right? You got AB plus AC. This one is normal, then we'll expand. But for this chapter, no, we are not doing like this. Okay, see how I do, huh? Memorize the formula. Sine A plus B means sine A cos B plus, okay, terbalik, cos A sine B. Okay, and if you have minus here, you follow the minus here. Okay, next, number 9. What about cos? Here means 2 formulas already, just like I said that got 6, right? So actually here we have 2 already. If here plus, we follow plus. If here minus, we follow minus, yeah? Okay, now we go cos. So cos, the formula is cos. This is sine cos, cos sine. But for cosine one, we got cos, cos A, cos B. Plus, okay, take note, if here plus for cosine, terbalik, we got minus. So we got cos, sin, or cos, Sine, yeah? If here plus, we got minus. If here minus, we got plus. Terbalik one. Okay, now we have 4 formulas already. Next, we go tangent. Okay, so tangent A plus B. I got tangent A plus tangent B. Here plus, right? Down there is minus. 1 minus tangent A, tangent B. If here minus, so here minus, here terbalik plus. Okay, means this is what I meant, the 6 formulas here. Okay? Can follow so far? This is what I said that just now, addition formula and double angle formula later. Yeah, I want you to understand this first. So far, can follow? Can understand these 6 formulas? Okay, so from this class now, I want to show you how to make use of these formulas, yeah? Now look at my 6.5. Make use of this to show you how to do, yeah? Okay, you copy down first class. Copy this 8, 9, 10 one. So means for the coming lesson, I'm not going to keep showing you this page, okay? So when I say formula, the first one, the second one, okay, I ask you to refer first, second, third, fourth, and so on, yeah? Okay, done, yeah, class. Now get ready to my questions. Okay, sis, without using a calculator, you're asked to find the value of this. Okay, I'll show you how you relate the formula from my right screen there, yeah, class? When questions say without using calculator, remember the specific angle that I have explained to you? The specific angle? Okay, we do some revision about the specific angle that you have learned, yeah, class? 30, 60, 45. So, okay, still remember this one? These two triangles, yeah? We do some revision. Okay, I ask you to memorize the 30 degree for sine 30, 1 over 2. With the Pythagoras theorem, square root of 3. So you know how to construct this one. Here you get 60 degree. And for specific angle, another one is 45. Memorize, tangent 45 is 1. Because this is isosceles triangle. Okay, 1. For Pythagoras theorem, here we got 2. Yeah, this one I have shown you, I've explained many times already, yeah, class? Okay, now look at my A. So now you must make it this to the angle that's stated here. As you know, 75, because you're not allowed to use calculator. As you know, 75, can you see 30 and 45? Yeah, because you use add or minus, yeah? So, sine 75, you make it sine 30 plus 45. After that, make use of this formula. Sine A cos B plus cos A sine B. Okay, then sine 30, you refer this triangle, 1 over 2. Cos 45, then this one, 1 over square root of 2. Cos 30, refer this one, cos 30, square root of 3 per 2. Sine 45, the same. Yeah, because not allowed to use calculator, you don't change it to decimal or what, yeah? So here, okay, you can see the denominator is the same. Here I got 1. Here I got square root of 3. Okay, there, done. Unless question said that leave your answer in a surd form to the simplest form, remember? You learn form 4, the chapter of surd, not to have the square root 1, remember? Actually, until here, your question didn't mention, so means until here accepted. Okay, we do some revision that you have learned in form 4, the chapter of surd, because you're not allowed to have this. You want to simplify the answer. So I multiply with square root of 2. So I have 2 times square root of 2 means 224. Okay, we apply this one. Square root of 2 with a square, we got 2. This times this, we got 2. So 224. And here, square root of 2 times 1, square root of 2. Square root of 2 times 3, you can write down 6. Okay? Or you just write like this also accepted. You don't expand it, then just write like this. It's okay one. Okay, not class? Okay, write down first, then later I want you to try. Okay, you copy this first. So can you send class? Yes, okay, good. I keep copy first, done, let me know, yeah? Done, yeah? Now, so class, you look at the B. There, cos, cos, sin, sin, there. Cos, cos, sin, sin, the plus one. When you change it back, you must make it minus the balik one, Okay, so means from here, for B, you tell that cos 80 minus 50. So you got cos 30. Just now the triangle they have deleted. I'm sure that you have that already, right? Previously we have copied. So cos 30 just now the triangle there is square root of 3 per 2. Okay, na? Okay, now class. Okay, your turn. I want you to try by referring the formula that given here. Okay, look at this, Tangent 15, I just hint you. Tangent 15. 15, you make it tangent 45 minus 30. Tangent 45 minus 30. Okay, tak payah. I rewrite this here. Because the sound I accidentally deleted, When you see 45, 1 square root of 2. When you see 30, 1 over 2 square root of 3 with a 60 degree here, okay? So 15 class, make it 45 minus 30. 45, tangent 45 minus 30. And you see D, sin A, cos B, cos A, sin B. You refer this formula. And tangent of cos, you refer this. Okay, I keep trying C until E now. Okay, done, is it class? Yeah, because some told me that done, right? Any of you need help? Okay, I write the answer. If any that you couldn't get, you let me know, So you check your answer. Just now until where? C, right? C I didn't write the third form one because question didn't ask to simplify it or to leave it in a square root of b form, yeah? D, I got 1, and E is also 1. Yeah, other than specific angle, 30, 45, and 60. Remember, I taught you already for the graph one. 0, 90, 180, 270, and 360, okay? Any of any help for CDE? C. Okay, so let me explain C class since you got any help for C, yeah? And listen to my explanation for C here, class. C. Tangent 45 minus 30, okay? Okay, so we got tangent A, follow minus, follow the formula, tangent B. Okay, here minus, down there plus. 1 plus tangent A, tangent B. Okay, tangent 45 is 1. You can refer this part, when I scroll through it. Okay, I continue. Tangent 30, 1 per square root of 3. 1 plus tangent 45 is 1. Tangent 30 is 1 per square root of 3. Okay, so whenever you see this type, actually I taught you already, I said the big per, you make it divide. The small per, you make it a single fraction. Here, square root of 3 minus 1, the square root of 3. I make it to the same denominator, okay? Down there, square root of 3 plus 1, square root of 3, the square root of 3, the top part, because this is square root of 3 per square root of 3 to make it to the same denominator. Okay, left side, I just copy, change the times, reciprocal. Then I simplified it, then I got this answer. Okay? And follow? Yes, huh? Okay, next. Which one? Oh, you want to simplify. Okay. Since you asked me this, if a question asks you to simplify, then you do it like this. Here is A plus B. You make it A minus B. Okay, class, since you asked me this one, okay, I show you. Yeah, I mean the third form one, right? For the chapter log 1. Okay, so class, now you see this one, if you want to simplify it, A plus B, A minus B, you got A squared minus B squared. Okay, not? Square of 3 square, you got 3. And the top part means A minus B times A minus B. I got A minus B squared. Okay, so see, I expand. A squared minus 2A B plus B squared. Here I got 2. So 3 plus 1, see, 3 plus 1, I got 4. Minus 2 times square root of 3 per 2. Okay, 4 per 2, I dapat 2. This and this simplify. You can leave the answer like that also. Yeah, you follow the chapter of log that you have learned, okay? How is it? Is it okay for 6.5 question 1 class? Do you have any to ask? Okay, I can follow, yeah? Can I delete? Okay, still need it, yeah? Okay, done, yeah? So class, for today, I want you to try this one as homework, okay? Just try by using this formula. You're asked to simplify. Simplify each of the following trigonometric function, then find its value using a calculator. Okay, this one you can use a calculator. Yeah, so I show you one of these, then you can try the rest. I show you A. Okay, look at A. You do it this way. Sin A cos B plus cos A sin B. The formula is sin, this one, sin A plus B. Okay, because here is the plus one. So sin A plus B means 25 plus 15. I got sin 40. Yeah, you show until here. Then find the value by using calculator. Okay, you can key in the calculator already for sin 40. Sin 40, I got 0.6428. Okay, can you understand? Yeah, okay, so class, I teach until here today. Mark down question 2, B and C as homework. Okay, so you're allowed to leave. Still have any question to ask? No questions, you're allowed to leave. Okay, see you. Bye-bye.